My name is Akindamidele. My mentor's name is Professor Ilona Crutchmark. My research facility is City College of New York, the Chemical Engineering Department. Now, for the past 2 weeks and a half, I've been studying asymmetric surface modification. Now, what asymmetric surface modification is simply to modify particle surfaces resulting in the creation of patchy particles. Now, a new question: what is patchy particles? Patchy particles are just particles that have one or more distinct patch or patches of different substances. As shown in the picture, this is one substance developer. Now, since patchy particle is such a new research topic, we are only limited to 2 patches. The simplest form of patchy particles is a Janus particle. Now, what is a Janus particle? A Janus particle is named after the Greek god with 2 heads on opposite ends. This Greek god, each head had a different personality, as well as the Janus particle. And the Janus particle is the only particle that has 2 equal patches, 50-50. Now, I'm going to start talking about how to make a Janus particle. And first, you'll need to know what a monolayer is. And in case you don't know, a monolayer is just a set of particles that is only 1 particle thick, shown in the picture. Now, each particle is about 1/10 of this as wide as a hair, so that's extremely small. Now, it's made up of polystyrene, and it's like a plastic-like substance. Polystyrene in a larger content, you can see it in like plastic CD cases, yogurt cups, and so on. Alright, so just to recap, first we have our monolayer of polystyrene, and next we're going to talk about the TED pellet. Now, the TED pellet is what we coat the monolayer with. This is a machine. You put your monolayer plate right here, and then the TED pellet disperses a metal vapor. Usually it's gold, but remember, since these particles are so small, it's pretty much worthless gold. And only half of the particle is exposed because it's just coming right from the top. Alright, so if you can see in this picture, this light area right here, this is a metallic covering, let's say it's gold. And this darker area, if you can see that on the side, that is the original polystyrene particle. Next, we're going to talk about silicon polymer, also known as PDMS. Silicon polymer originally come as a liquid, as you can see in here. And right when you add heat, the compounds that are attaching them together get stronger, so they become solid. And before it's like a gel-like liquid, and then it becomes like a plastic-like rubbery plastic. Yeah. So you usually see this in like rubber bands, not rubber bands, but like a band they wear on your hand. Now, so we're gonna take this plate of glass and the layer of gold, and then we're going to put it into the liquid form of the PDMS. Then we're going to solidify it by adding heat. and then it will become a harder substance. So then we can just peel the plate off the particles, and you'll pretty much just have this. Now we have to recreate step number 2. This time, we're going to put it back to the 10 kilo, and this time we're going to add a different type of material, metallic material. Let's say it's copper. So let's say these little things right here, that's all copper. And on the bottom, that's gold. Okay, so then after we have all the 2 sides, we just put it into like we just pretty much soak the PDMS, and it just releases the particles each. So we just have each of the particles just flowing in the water. Alright, so we successfully made a genus particle. Alright, so I just showed you how to make a genus particle, but what is the importance of a genus particle? Sorry about that typo right there. The genus particles can be used as emulsions, and emulsions are 2 substances that cannot mix. Example of emulsions are water and oil. Now, this is something that we can connect to everyday life. When we try to take out oil from mines, we have to use water to have the pressure to take it out, but there's a problem. The oil doesn't actually follow the water. So instead, scientists put soap in the water, and then the soap interacts with the oil, and then it comes out. But there's a new problem. If we want to use this oil, how are we going to have soap in it? So they'll have to evaporate the soap. It'll take much longer time. So what we're hoping to do, instead of having the metal, the 2 metal bases, the gold and the copper, instead we can have water and soap back to back. So this time we can have the soap and water, but since the soap will now be an emulsion, it won't actually follow the oil, so we can just filter that easily out. And now this way it can be easier to extract the soap. Now our second goal is we're trying to create different types of patchy particles other than the genus particle and other particles that just have a smaller patch. Instead, we could have more than one little patch in the center. Different patches here. These are 3 patches, 3 patches, 3 patches. Just different ways. 2 patches and 1 middle patch. Just different ways. And now I credit Dr. Akindamidele, my mentor, Harlem Sugar Society, Francisco G, and Dr. Sack.